Hi, my name is Lauren Hoffer, and I'm going to go over the procedure for the Fourier transform infrared spectroscopy principal component analysis for vegetable oil determination experiment. So the first part, you would usually make standard solutions, but in this case, you just have to make sure you have all the solutions that are required, which are 6 oil standards of avocado, canola, hemp, sesame, olive, and safflower oils, the 2 unknown samples, and dichloromethane to clean the zinc selenide attenuated total reflectance sampling accessory, or the ATR sampling accessory. And then the second part of the experiment is the adjustment of the FTIR instrument parameters. First parameter that you're going to maximize is the signal to noise ratio, which is done by setting the spectrometer to percent transmittance at a resolution of 1 wave number to collect 1 scan. You will collect to do this whole process for the different scans, you will collect a background spectrum, reprocess the background to percent transmittance, collect another spectrum, and take a ratio of the second spectrum to the background spectrum. And you will repeat this with 4 scans, 16 scans, and 64 scans to see the best number of scans to use later on in the experiment. And the second parameter that will be maximized is resolution. You will insert the ATR accessory in the experiment and clean it with DCM. This is going to be cleaning the ATR accessory with DCM is going to be crucial for the rest of the experiment because you don't want to contaminate the ATR accessory. Otherwise, your data will not come out clean. You will collect a background spectrum, then collect spectra for a sample of canola oil at resolutions of 0.5, 1, 4, 8, and 16 wave numbers to see which resolution is best. And then once you maximize these two variables, the resolution and the number of scans, you will use these parameters for the analysis of the known oils. You will acquire 4 absorbance spectra of the 6 pure oils, making sure to clean the ATR accessory between samples, and the spectra will be collected over the wave number range of 600 to 4,000 wave numbers. So you will graph 1 spectrum for each of the oils on a single plot and select 7 peaks that are roughly the same across all of the spectra. You want to do this preferably in the fingerprint region, which is 500 to 1,500 wave numbers, because this is the region that is most unique to each type of compound or each type of oil in this case. So you will want to pick the highest point of each peak. And so as you go down, these numbers will all be consistent for peak 1. And this just makes you want to make a spreadsheet because it'll be an organized way to keep all your data together. This part 4 is the principal component analysis, and you will first use the ATR accessory to collect IR spectra of the 2 unknown samples, and you will add the peak information into the spreadsheet. And the reason this spreadsheet is important is because the data from the spreadsheet will be imported into MATLAB to perform the PCA analysis. You will make 2-axis and 3-axis PCA plots in MATLAB to see if the unknowns overlap with any of the known oils. And then for part 5, you'll be doing another technique to identify the oils called the nearest means classification. And you will use the same data from the same spreadsheet. This is just another technique that will either help or hinder you from seeing the identification of your oils. So you will decide which technique is better, the PCA or the NMC classification or nearest means classification. So that is pretty much it for the Fourier transform infrared spectroscopy experiment. Thank you very much.